Picture this: a swirling vortex of cosmic fury, stretching across light years, with winds so ferocious they could tear entire worlds from their orbits and hurl them into the endless dark. This isn't the plot of a blockbuster sci-fi movie. It's real. It's happening right now, somewhere in the vast expanse of our universe. Welcome to the incredible story of the galactic tornado, a phenomenon so powerful it sends planets spiraling into interstellar exile, forever adrift among the stars. What could possibly unleash such chaos? Think of the most violent storm you've ever seen: a hurricane, a tornado, a tempest that reshapes landscapes in its wake. Now multiply that by 1 billion. Galactic tornadoes are born from the unimaginable forces at play in the hearts of galaxies, where supermassive black holes, colliding star systems, and titanic magnetic fields collide. These aren't just storms, they're cosmic wrecking balls, rewriting the fate of anything unlucky enough to cross their path. And the most chilling part: somewhere out there, right now, a planet like ours could be ripped from its home, set adrift on a one-way journey into the unknown. But here's what truly blows my mind: this isn't just a spectacle of destruction. It's a clue, a cosmic puzzle piece that could help us unravel some of the universe's biggest mysteries. How do planets survive such violence? Could life hitch a ride on these exiled worlds? And what does it mean for our own place in the cosmos? Strap in, because today we're diving deep into the science behind these galactic tornadoes, exploring how they form, the mind-bending physics at play, and the eerie trail of rogue planets they leave behind. By the time we're done, you'll never look at the night sky the same way again. Imagine taking the most powerful tornado on Earth and scaling it up to galactic proportions, where instead of wind and debris, you've got swirling currents of gravity, radiation, and warped spacetime. That's what we're dealing with when we talk about galactic tornadoes. These aren't just storms, they're cosmic whirlpools of destruction, born from the most violent events in the universe. Picture two galaxies colliding, their supermassive black holes spiraling toward each other, churning up spacetime like a blender set to cosmic overdrive. Or a dying star exploding with such force that it sends shockwaves through its entire system, twisting the fabric of reality around it. These are the kinds of events that spawn these monstrous phenomena. And here's where it gets even wilder: these tornadoes don't just fling around dust and gas. They can grab entire planets, yanking them from their orbits and hurling them into the void. Think about that for a second. A world like ours, minding its own business in the Goldilocks zone of its star, suddenly caught in the grip of forces so immense that its entire future is rewritten in an instant. Scientists call these exiled worlds rogue planets, and they might be far more common than we ever imagined. Some estimates suggest there could be billions of them drifting through the darkness between stars, silent witnesses to the chaos that once tore them from their homes. But how does something like this even happen? It all comes down to gravity's twisted dance. When galaxies merge or black holes feast on surrounding matter, they don't just pull things in, they spin them, stretch them, and sometimes eject them at unimaginable speeds. It's like a cosmic slingshot, where the forces at play are so extreme that planets can be flung outward like pebbles from a spinning tire, and once they're loose, there's no going back. No star to warm them, no orbit to stabilize them, just an endless journey through the freezing depths of interstellar space. Yet, as terrifying as that sounds, there's a strange beauty in it. These events aren't just random acts of destruction. They're part of the universe's grand recycling program, scattering raw materials across the cosmos, seeding new star systems, and maybe, just may be carrying the ingredients for life to new corners of the galaxy. Who knows, one of these rogue worlds cast adrift by a galactic tornado might someday find itself in a new solar system, under a new sun, with a fresh chance at something extraordinary. The universe works in mysterious ways, and sometimes its most violent storms are just the beginning of something new. To understand how these galactic tornadoes are born, we have to look at some of the most violent events in the universe: collisions between entire galaxies. Picture two massive spirals of stars, gas, and dark matter smashing into each other in slow motion over millions of years. At first, it might seem like a graceful dance, but beneath that beauty lies chaos. As these galaxies merge, they're supermassive black holes, each weighing billions of times more than our sun, begin circling one another in a deadly spiral. The closer they get, the faster they spin, warping spacetime around them like a whirlpool. This isn't just gravity at work. It's gravity on steroids, twisting everything in its reach into a frenzy. But the real fireworks start when these black holes finally collide. The impact sends ripples through space-time itself, gravitational waves that distort the fabric of the cosmos. Think of it like tossing a boulder into a still pond, only instead of water, the ripples are stretching and squeezing reality. That energy has to go somewhere, and in this case, it whips surrounding gas, dust, and even entire star systems into a maelstrom. The result, a cosmic tornado, where winds of superheated plasma and twisted magnetic fields rage at speeds we can barely comprehend. And that's just one way these monsters are born. Another possibility comes from the heart of an active galaxy, where a supermassive black hole is feasting on surrounding matter. Sometimes, instead of swallowing everything, these black holes spit out jets of energy and particles at nearly the speed of light. When these jets slam into surrounding gas clouds, they create shockwaves so powerful they can carve out cavities in space, literally blowing bubbles of chaos that trigger violent turbulence. Imagine a jet engine blasting through fog, but on a scale so vast it reshapes entire regions of a galaxy. What ties these scenarios together is sheer disruption. Whether it's colliding black holes or erupting galactic cores, the common thread is a sudden, catastrophic release of energy that throws everything off balance. And when that happens, planets minding their own business in stable orbits suddenly find themselves in the crossfire. One moment, they're peacefully circling their star. The next, they're caught in a gravitational riptide, ripped from their homes and sent tumbling into the abyss. But here's the twist. These events aren't just random acts of destruction. They're part of a cycle as old as the universe itself. Galactic tornadoes might scatter worlds into the void, but they also redistribute the raw materials for new stars, new planets, and maybe even new life. The same forces that exile planets could someday plant the seeds for something new in another corner of the galaxy. It's a reminder that even in the chaos of the cosmos, there's a strange kind of order, a balance between creation and destruction that's been playing out since the dawn of time. Now let's peel back another layer of this cosmic mystery: dark matter. It's the universe's silent architect, an invisible force that makes up most of the matter in galaxies, yet refuses to interact with light. We can't see it, we can't touch it, but its gravitational grip is what keeps galaxies from flying apart. And when it comes to galactic tornadoes, dark matter might be the hidden conductor orchestrating the chaos. Recent supercomputer simulations reveal something astonishing: that dark matter doesn't just sit idly by during these cosmic storms. It amplifies them. Imagine a magnifying glass focusing sunlight into a scorching beam. Dark matter halos, those vast, ghostly cocoons surrounding galaxies, could be doing something similar with gravity. As a galactic tornado forms, the dark matter's gravitational pull might concentrate and intensify the swirling forces, turning what would have been a destructive event into an outright cataclysm. Without this unseen influence, these storms might never reach the ferocity needed to rip planets from their orbits and send them careening into the void. But here's where it gets even stranger. Dark matter's role isn't just about brute strength, it's about structure. Think of a galaxy like a whirlpool in water. The visible stars and gas are just the surface froth, but the real motion comes from deeper currents, the dark matter. When galaxies collide or black holes merge, it's the dark matter that shapes how the chaos unfolds, guiding the torrents of energy into tighter, more violent spirals. In a way, these tornadoes aren't just random acts of destruction. They're sculpted by the invisible hand of dark matter, a force we're only beginning to understand. This raises a profound question. If dark matter can amplify galactic tornadoes, what else is it doing that we haven't discovered yet? Could it be quietly shaping other extreme cosmic phenomena, from the birth of supermassive black holes to the formation of the universe's largest structures? Every clue we uncover about dark matter peels back another layer of the universe's secrets, and galactic tornadoes might just be one piece of a much larger puzzle. What's clear is this: the more we learn about these invisible forces, the more we realize how much of the universe operates in the shadows. Dark matter isn't just a passive backdrop. It's an active player in the cosmic drama, twisting the fabric of reality in ways we're only starting to grasp. And as we unravel its mysteries, we might finally understand why some planets are doomed to wander the interstellar abyss, exiled by storms born in the unseen depths of the cosmos. So what does it take to fling an entire planet into the void? We're not talking about a gentle nudge. This is cosmic eviction at unimaginable speeds. Picture a marble launched from a slingshot, but instead of a rubber band, it's the gravitational fury of a galactic tornado doing the flinging. Scientists estimate these exiled worlds can reach velocities of thousands of kilometers per second, so fast they're not just leaving their star systems, they're breaking free from their entire galaxy's gravitational grip. To put that in perspective, at those speeds, you could cross the distance from Earth to the Moon in less than a minute. The secret behind this extreme acceleration lies in something called the slingshot effect. You've probably heard of NASA using planetary gravity to boost spacecraft like a cosmic freeway where planets act as speed-boosting ramps. But in the chaos of a galactic tornado, this effect gets dialed up to 11. Here's how it works. As a planet gets caught in the tornado's swirling currents, it's whipped around like a tetherball, gaining speed with each pass. The tornado's rotational energy, a combination of gravity, magnetism, and sheer cosmic turbulence, acts like an invisible catapult. And when the timing's just right, the planet is flung outward with enough force to overcome even the pull of its home galaxy. But here's where it gets even wilder. Some of these ejected planets don't just wander to the edges of their galaxy, they go interstellar. Imagine a world traveling so fast it becomes a permanent nomad, drifting through the black expanse between galaxies with no star to call home. These rogue planets might spend billions of years in freezing isolation, their surfaces locked in eternal darkness. And yet, against all odds, some could still harbor secrets beneath their icy shells. Recent theories suggest that tidal forces, or even internal heat from radioactive decay, might keep underground oceans liquid, raising the tantalizing possibility that life, in some form, could survive these epic journeys. The physics behind these ejections is a reminder of just how dynamic and ruthless the universe can be. One moment, a planet is orbiting peacefully. The next, it's a speck in the rearview mirror of its own galaxy. But there's a strange poetry to it too. These exiled worlds aren't just casualties, they're explorers, carrying the potential for life across unimaginable distances. Who knows, one of them might even be heading toward a new home, destined to circle a different star millions of years from now. The universe doesn't just destroy, it redistributes, reshapes, and sometimes, against all odds, gives castaways a second chance. Could a planet actually survive being hurled into the void by a galactic tornado? It sounds like a death sentence, a one-way ticket to oblivion, but the universe loves defying expectations. Some worlds might just have what it takes to endure this cosmic eviction, and the key lies in their very structure. Take gas giants, for example. These massive planets, like Jupiter or Saturn in our own solar system, are built differently. Their thick, swirling atmospheres act like cosmic shock absorbers, cushioning them against the brutal forces at play during ejection. Those layers of hydrogen and helium aren't just for show. They're a protective blanket, shielding the planet's core from radiation, debris, and the extreme temperature swings of interstellar space. But not all planets are so lucky. Smaller, rocky worlds like Earth would face a far grimmer fate. Without the cushion of a dense atmosphere, the sheer gravitational whiplash of a galactic tornado could rip them apart. Imagine a mountain range being peeled away layer by layer, or an entire crust cracking under the strain. The physics is unforgiving. These planets simply aren't built to withstand such violence. They'd likely fragment into rubble, joining the countless debris fields scattered across the cosmos. Yet here's where the story takes a fascinating turn. Even in the freezing darkness of interstellar space, life might find a way. Some rogue planets, especially those with subterranean oceans, could cling to warmth deep beneath their icy surfaces. Tidal forces from a surviving moon or heat from radioactive decay might keep these hidden oceans liquid, a lifeline for any organisms trapped beneath the ice. We've seen hints of this possibility right here in our own solar system. Europa, one of Jupiter's moons, and Enceladus, orbiting Saturn, both have subsurface oceans that could harbor microbial life. Now picture a rogue planet cast adrift but still holding onto that inner heat. It's not impossible that somewhere in the void, a lonely world carries the flicker of life, frozen in time but not extinguished. The real mind bender, these exiled planets might not be forever alone. Over millions or even billions of years, a rogue world could be captured by another star, pulled into a new solar system like a cosmic orphan finding a home. Suddenly, that frozen wasteland could thaw, its hidden oceans stirring back to life under the warmth of an alien sun. It's a long shot, sure, but the universe has time. And if there's one thing we've learned, it's that life is stubborn. It clings to existence in the most hostile corners of our own planet, from scorching hydrothermal vents to the icy plains of Antarctica. Why not on a wandering world drifting between the stars? So while a galactic tornado might spell doom for some planets, for others, it could be the start of an epic journey, one that lasts eons and crosses unimaginable distances. And who knows, maybe right now, somewhere in the endless dark, a rogue planet carries the seeds of life, waiting for its next chapter to begin. Spotting a rogue planet drifting alone in the endless dark might seem impossible after all. These cosmic exiles emit no light of their own, and they're often billions of miles from the nearest star. But astronomers have cracked the code, using some of the most ingenious tricks in modern science to track down these elusive wanderers, one of their most powerful tools. A phenomenon called microlensing. Here's how it works. When a rogue planet passes directly between us and a distant star, its gravity acts like a magnifying glass, bending and amplifying the star's light for a brief moment. From Earth, that star suddenly brightens just for hours or days before fading back to normal. It's a tiny blip in the data, but for scientists, it's a flashing neon sign pointing straight to an invisible world. Microlensing is like catching a shadow in a pitch-black room. You can't see the object itself, but you know it's there because of the way it distorts the light behind it. And the most fascinating part, this technique doesn't just reveal the planet's presence. By studying how long the brightening lasts and how intense it gets, astronomers can even estimate the rogue world's mass and distance. It's cosmic detective work at its finest, turning subtle clues into hard evidence of planets we'd never see otherwise. But microlensing isn't the only way to hunt these exiles. Some rogue planets carry a faint, lingering warmth from their violent birth heat, trapped beneath layers of ice or within their cores. Advanced telescopes like the James Webb Space Telescope are designed to pick up this whisper of infrared radiation, spotting these worlds as dim, glowing specks against the freezing backdrop of space. It's like using thermal goggles to find a warm rock in a snowstorm. And sometimes, if we're lucky, these planets even leave behind traces in the form of swirling debris clouds, the shattered remains of moons or atmospheres torn apart during their ejection. Every discovery adds another piece to the puzzle. A microlensing event here, a faint heat signature there, each one helps scientists map out the hidden population of rogue planets lurking in our galaxy. And the numbers are staggering. Some estimates suggest there could be 20 times more rogue planets than stars in the Milky Way. That means billions of worlds untethered from any solar system, drifting silently through the void. But why does this matter? Because these exiled planets are more than just cosmic curiosities. They're time capsules carrying clues about how planetary systems form and how they fall apart. By studying them, we're essentially reading the diary of our galaxy's most violent history, page by page. Every rogue planet we find is a survivor of chaos, a testament to the unimaginable forces that shape the universe. And who knows, one day, we might even find one close enough to visit a frozen world adrift in our own stellar neighborhood, waiting to tell its story. Where do these exiled planets go once they're flung into the void? The answer is as vast and unpredictable as the cosmos itself. Some become eternal wanderers, drifting through the interstellar darkness for billions of years, never again feeling the warmth of a star. Others might get a second chance snatched from the abyss by the gravitational pull of a passing star or even an entire solar system. Picture a cosmic game of catch, where the universe itself decides which planets are doomed to solitude and which might find a new home. Take the case of a rogue planet drifting too close to another star system. Gravity, ever the matchmaker, could bend its trajectory just enough to pull it into orbit. It's not a gentle process, more like a high-speed cosmic heist, where the planet's momentum and the star's gravity negotiate a chaotic dance. If the conditions are just right, the planet might settle into a new orbit, becoming an adopted world in a foreign solar system. Scientists call these captured planets, and they could be hiding in plain sight, masquerading as native members of their new stellar families. But here's the twist: some of these adopted planets might not settle into neat, circular orbits like Earth. Instead, they could end up on wild, elongated paths, swinging close to their new star before hurtling back into the icy depths of their system. These extreme orbits would create bizarre seasonal cycles, brief, scorching summers followed by eons of frozen darkness. Imagine a world where the concept of a year stretches for centuries, with climates so unstable that life, if it existed at all, would have to endure unimaginable extremes. And then there's the rarest possibility of all, a rogue planet not just captured by a star but by another planet. Gas giants, with their immense gravitational pull, could theoretically snag a drifting world and force it into becoming a moon. It's a long shot, but if it happened, the result would be a moon unlike any other one with a history of interstellar exile, a silent witness to the chaos of galactic tornadoes. What's truly mind-bending is that this isn't just speculation. Astronomers have already spotted potential candidates planets in distant systems with orbits so unusual that they almost have to be interlopers, adopted from the cosmic wilderness. Each one is a clue, a piece of evidence that the universe is far more dynamic than we ever imagined. Planets aren't just born into their orbits, some are stolen, rescued, or even traded in gravity's grand marketplace. So the next time you look up at the night sky, remember, some of those pinpricks of light might not just be stars. They could be the adopted homes of wandering worlds, planets that once knew only darkness, now given a second chance under an alien sun. The universe doesn't just destroy, it rearranges, recycles, and sometimes, against all odds, offers a lonely world a new beginning. The Milky Way seems so serene when we gaze up at its shimmering band of stars, but looks can be deceiving. Beneath that tranquil facade lies evidence of a turbulent past, scars from ancient cosmic storms that once raged through our galactic home. Those strange, looping rivers of stars we've spotted, stellar streams arcing through the halo of our galaxy, aren't just random patterns. They're the debris trails of smaller galaxies torn apart by the Milky Way's gravitational fury, cosmic crumbs left behind after a violent feast, and tucked among them, rogue planets drifting like ghosts between the stars, silent witnesses to a time when our galaxy was anything but peaceful. Take the famous Gaia sausage, for example. This bizarre cluster of stars orbits the Milky Way at extreme angles, like a splintered spine cutting through our galaxy's orderly disk. Astronomers believe it's all that remains of a dwarf galaxy that collided with ours billions of years ago, a collision so violent it didn't just scatter stars. It likely unleashed gravitational shockwaves powerful enough to mimic the very tornadoes we've been exploring. Picture the chaos, two galaxies merging, their black holes spiraling toward each other, churning up spacetime like a whirlpool. Any planets caught in that maelstrom would have been flung outward like stones from a slingshot, some escaping entirely to become the rogue worlds we detect today. But the clues don't stop there. Look at hypervelocity stars' lonely suns racing through the galaxy at speeds so absurd they're essentially fleeing their birthplaces. These aren't just random runaways. Many trace their origins back to the galactic center, where the supermassive black hole, Sagittarius A, lurks. When binary star systems wander too close, the black hole's gravity can rip them apart. One star swallowed, the other catapulted outward at mind-bending speeds. If stars can be ejected this way, why not planets? In fact, some of the rogue planets we've detected might have been passengers on these high-speed stars, torn away during their chaotic expulsion and left to drift alone. Then there's the case of the Magellanic Stream, a colossal ribbon of gas stretching across the southern sky. It's the aftermath of the Milky Way's gravitational tug-of-war with its two largest satellite galaxies, the Large and Small Magellanic Cloud. As these galaxies orbit ours, the Milky Way's tidal forces strip away their gas, creating this shimmering river of matter. But simulations suggest the interaction goes deeper. Their repeated passes could have stirred up gravitational eddies, temporary tornado-like turbulence capable of shaking loose planets from both the clouds and our own galaxy's outskirts. So what does this mean for us? If the Milky Way has weathered these storms before, could another be on the horizon? Astronomers are already tracking a future collision with the Andromeda Galaxy, set to unfold in about 4 billion years. When it happens, the gravitational chaos could spawn tornadoes far more violent than anything in our past, reshaping orbits, ejecting worlds, and rewriting the cosmic map of our neighborhood. But here's the silver lining. These cataclysms aren't just destructive. They're creative forces scattering the raw materials for new stars, new planets, and perhaps even new chances for life. Our own solar system might owe its existence to such an event, a long-ago storm that seeded the ingredients for the Sun and Earth. The deeper we dig into our galaxy's history, the clearer it becomes. The Milky Way isn't a static island of stars. It's a living, evolving beast shaped by cycles of chaos and calm. Those rogue planets and twisted stellar streams aren't anomalies. They're chapters in an epic story, one where even the most violent storms can sow the seeds for something new. And if we're here today, it's because the universe has a way of turning destruction into opportunity, one galactic tornado at a time. At the heart of nearly every galaxy, including our own Milky Way, lurks a monster, a supermassive black hole, an entity so dense that not even light can escape its grip. These cosmic titans aren't just passive observers of galactic tornadoes. They're often the architects, their gravitational might warping spacetime into spirals of pure chaos. Picture a whirlpool in a bathtub, but instead of water, it's the fabric of reality itself twisting, dragging everything nearby into a frenzied dance. When two galaxies collide, their central black holes spiral toward each other, churning up spacetime like a blender set to cosmic overdrive. The energy released in this process doesn't just stir the pot, it launches shockwaves that can rip entire star systems apart. But here's where it gets even more fascinating. Some supermassive black holes don't just create chaos, they thrive on it. As a galactic tornado rages, swirling currents of gas, dust, and even stars are funneled toward the black hole's event horizon, the point of no return. This isn't a gentle sip, it's a cosmic feast, with matter falling in at such incredible speeds that it heats up to millions of degrees, glowing brighter than all the stars in the galaxy combined. Astronomers call these active black holes quasars, and they're among the most luminous objects in the universe. The energy they release can outshine entire galaxies, lighting up the cosmos like a beacon. Yet, as terrifying as this sounds, there's an unexpected twist. These black holes might actually regulate their galaxies. Think of them as cosmic pressure valves. When they feed too greedily, the radiation they emit can push away surrounding gas, starving themselves and slowing their growth. It's a self-balancing act where the very destruction they cause eventually puts limits on their power. This delicate dance between chaos and control might explain why we don't see galaxies ripped apart by their own black holes more often. The universe, it seems, has a way of keeping its monsters in check. But the real jaw-dropper, some of these black holes don't just fling planets into exile, they might create them in the process. When stars are torn apart by tidal forces, their debris doesn't always vanish into the black hole's maw. Some of it gets spun outward at incredible speeds, forming vast, swirling disks of superheated material. In these extreme environments, the conditions might be just right for new planets to form, not around stars, but around the black hole itself. Imagine a world born from the ashes of destruction, orbiting the very force that doomed its predecessors. It's a cosmic irony of the highest order, where creation and destruction are two sides of the same coin. So the next time you hear about a rogue planet drifting through the void, remember, its story might not begin with a star, but with a black hole's appetite. These galactic tornadoes, fueled by the universe's most destructive forces, don't just erase worlds, they reshape them, scattering the pieces across the cosmos and sometimes against all odds, building something new from the wreckage. The universe doesn't just destroy, it reinvents. And at the center of it all, pulling the strings, are these enigmatic giants, proving once again that even in chaos, there's a strange and beautiful order. The universe is a silent movie. No sound waves can travel through the vacuum of space, no matter how violent the event. but if you could listen to the cosmos with something other than your ears, you'd hear a symphony of chaos. Galactic tornadoes don't just tear through space, they ring it like a bell, sending gravitational ripples echoing across the cosmos. These aren't sound waves in the traditional sense. They're distortions in spacetime itself, vibrations left behind when black holes collide, galaxies merge, or entire star systems are ripped apart. And thanks to cutting-edge observatories like LIGO, the Laser Interferometer Gravitational Wave Observatory, we're finally tuning in to this hidden frequency of the universe. Imagine throwing a pebble into a still pond. The ripples spread outward, carrying energy far beyond the initial splash. Now replace the pebble with two supermassive black holes locked in a death spiral, and the pond with the fabric of reality. That's what gravitational waves are, ripples in spacetime so powerful they stretch and squeeze everything in their path, including the Earth itself. When a galactic tornado forms, the colossal forces at play don't just fling planets into the void. They send shockwaves through the universe that literally bend the dimensions we live in. And LIGO's job is to catch these tremors, translating them into signals we can analyze. Here's how it works. LIGO detectors are essentially the most sensitive rulers ever built. Each facility consists of two 4-kilometer-long tunnels arranged in an L shape, with lasers bouncing back and forth inside them. When a gravitational wave passes through, it subtly changes the length of these tunnels by less than the width of a single proton. That's right. These waves warp spacetime so faintly that detecting them requires measuring shifts 1,000 times smaller than an atomic nucleus. Yet when LIGO picks up a signal, the data tells a story of unimaginable violence: black holes merging, neutron stars colliding, or in rare cases, the birth throes of a galactic tornado. The most incredible part, these waves aren't just noise, they're a language. Each signal has a unique fingerprint, a pattern of peaks and valleys that reveal the mass, spin, and distance of the objects involved. Some waves sound like a quick chirp, the final milliseconds of two black holes spiraling into one another. Others resemble a slow, building crescendo, the groan of a dying star being shredded by tidal forces. And hidden in that cosmic static might be the telltale signature of a galactic tornado, a prolonged, chaotic rumble as planets are torn from orbits and spacetime itself is twisted into knots. But gravitational waves aren't just about eavesdropping on destruction. They're reshaping our understanding of the universe. Before LIGO, we studied the cosmos mostly through light telescopes capturing photons from stars, galaxies, and nebulae. Now we're exploring an entirely new spectrum, the vibration of spacetime. It's like going from silent films to surround sound overnight. Suddenly, events that were invisible to traditional astronomy, like collisions in pitch-black voids or the inner workings of galactic tornadoes, are broadcasting their secrets loud and clear. And the discoveries are already rewriting textbooks. In 2015, LIGO detected its first gravitational waves, confirming a prediction Einstein made a century earlier. Since then, it's spotted dozens of events, each one peeling back another layer of cosmic mystery. Some signals hint at black holes of impossible sizes, others at exotic objects we didn't know existed. And while we haven't yet captured the unmistakable ripple of a galactic tornado, the math says it's only a matter of time. When we do, it'll be like hearing the roar of a hurricane from thousands of light years away, a reminder that even in the silence of space, the universe is never truly quiet. So the next time you gaze at the night sky, remember, there's more to the cosmos than meets the eye or the ear. Beneath the stillness, spacetime itself is humming with the echoes of ancient cataclysms, carrying stories of chaos and creation across the ages. And with every new detection, we're not just listening to the universe, we're learning its language. The sheer devastation left in the wake of a galactic tornado is almost incomprehensible. Entire star systems, once bustling with planets, moons, and asteroids, reduced to cosmic rubble in mere moments. Picture a celestial demolition derby where gravity is the wrecking ball, smashing worlds together with enough force to shatter continents or flinging them into paths of lethal radiation. Some planets collide head-on, their cores merging in a flash of molten fury. Others are ripped apart by tidal forces, their fragments scattered like shrapnel across interstellar space. And then there are the unlucky ones that drift too close to the tornado's core, where temperatures soar to millions of degrees, hot enough to vaporize rock, metal, even entire atmospheres in an instant. But the destruction doesn't stop there. The radiation unleashed by these storms is another silent killer. Imagine a supernova's fury concentrated into a swirling beam, sweeping through star systems like a scythe. Planets that avoid collisions might still find their surfaces scorched barren, their oceans boiled away, their atmospheres stripped by the relentless onslaught of high-energy particles. Even gas giants with their deep protective layers aren't safe. Their mighty hydrogen envelopes can be eroded over time, leaving behind skeletal cores, dead worlds adrift in the void. What's left behind is a graveyard unlike any other. Debris fields stretch for light years, littered with the remnants of what once were thriving planetary systems. Twisted metal from shattered cores, chunks of frozen mantle, and the ghostly traces of vaporized atmospheres drift in chaotic orbits, caught in the tornado's fading gravitational wake. Some of this wreckage might eventually clump together, forming bizarre hybrid objects, worlds stitched together from the pieces of others, like cosmic Frankenstein monsters. Others become rogue asteroids doomed to wander eternally between the stars. Yet amid the devastation, there's a strange kind of beauty. These wreckage fields are more than just scars, they're time capsules. By studying them, astronomers can reconstruct the violence of the original storm, piecing together how fast it moved, how powerful it was, and even what kinds of planets it destroyed. The distribution of debris tells a story, like forensic evidence at a crime scene. Heavy elements tend to cluster in certain areas, lighter ones in others, painting a vivid picture of the forces at play during the cataclysm. And here's the most haunting thought: some of this wreckage might still be moving. Planets or fragments ejected at high speeds could be traveling through the galaxy right now, cold and dark, their journeys far from over. A few might even pass through our own solar system one day, silent visitors from a disaster that unfolded billions of years ago. The universe doesn't clean up after itself. It leaves the evidence lying around, waiting for us to piece together the story. So when we look up at the night sky, we're not just seeing stars. We're seeing the aftermath of countless cosmic storms, the survivors and the victims, the worlds that made it and the ones that didn't. Galactic tornadoes might be rare, but their legacy is written across the heavens, a reminder that even in the vastness of space, nothing lasts forever. Galactic tornadoes might be the universe's ultimate high-stakes lottery, a cataclysmic event so rare that most galaxies will experience just one or two in their entire lifetimes. Think of it like a cosmic hurricane season where the storms don't come for billions of years, but when they do, they rewrite the rules of existence. The numbers are staggering. While smaller-scale chaos like supernova or asteroid impacts happen relatively often in cosmic terms, a full-blown galactic tornado is a once-in-an-epoch phenomenon. For context, our Milky Way has likely witnessed fewer than a handful since its birth over 13 billion years ago. That's rarer than a single grain of sand in a desert the size of a planet. But why are these events so vanishingly uncommon? It all comes down to the perfect storm of conditions required to ignite one. First, you need a trigger of unimaginable violence, something like two supermassive black holes colliding or a galaxy merging with another of comparable size. These aren't everyday occurrences. Even when galaxies do collide, they often pass through each other like ghosts, their stars so spread out that direct hits are unlikely. It's only when their central black holes finally spiral together, stirring spacetime into a frenzy, that the real chaos begins, and that dance can take millions of years just to begin. Then there's the fuel. Galactic tornadoes don't run on thin air. They require vast reservoirs of gas, dust, and stars to feed their fury. In younger galaxies, these materials are plentiful, but as a galaxy ages, star formation slows and the raw ingredients for chaos dwindle. By the time a galaxy like ours reaches middle age, it's simply too lean to sustain such a storm without an external catalyst. That's why these events often peak during the universe's wild youth, when galaxies were smaller, denser, and more prone to catastrophic collisions. Today, the cosmos is calmer, more spread out, less like a mosh pit, and more like a quiet dinner party where the guests politely keep their distance. Yet here's the paradox: despite their rarity, galactic tornadoes leave fingerprints everywhere. Their influence isn't just about the planets they exile or the stars they shred, it's about the legacy they imprint on entire galaxies. Take the distribution of stars in a galaxy's halo, for example. Those graceful, looping streams of stars orbiting far from the galactic center, many are the scars of ancient tornadoes, their orbits twisted by long-ago turbulence. Even the chemical makeup of a galaxy bears their mark. These storms churn up gas and dust, mixing elements forged in stellar cores and scattering them like cosmic fertilizer, seeding future generations of stars and planets with the building blocks of life. So while we might never witness a galactic tornado firsthand, their ghosts are all around us. Every rogue planet drifting through the void, every oddly angled star cluster, even the very atoms in our bodies might trace back to one of these rare cataclysms. The universe has a way of turning its rarest, most violent moments into enduring threads in the tapestry of existence. And that's the real mystery, not just how often these storms occur, but how deeply they shape everything that comes after. Among all the forces shaping galactic tornadoes, none are more enigmatic than magnetic fields, invisible threads weaving through space, capable of bending the very fabric of reality. These aren't just gentle ripples, they're titanic rivers of energy, strong enough to warp the paths of stars and sculpt the fury of cosmic storms. Picture a tornado on Earth, its funnel twisting and turning at the mercy of wind currents. Now replace those winds with magnetic filaments, each one trillions of times more powerful than Earth's entire magnetic field. That's the kind of force we're dealing with, a force that doesn't just influence the storm but shapes it, guiding its chaos like an unseen hand. How does this work? Imagine pouring molten metal into a maze. The liquid follows the channels, constrained by the walls. Magnetic fields act similarly in galactic tornadoes, creating invisible corridors that funnel superheated plasma and radiation into concentrated jets. These jets can stretch for thousands of light years, punching through gas clouds and even piercing neighboring galaxies. But here's the twist: while they amplify destruction in some areas, they might also offer pockets of eerie calm. Planets caught in these magnetic shadows could avoid the worst of the storm's wrath, shielded by forces they can't even perceive. It's like being in the eye of a hurricane, where the surrounding violence is muffled by an invisible barrier. Then there's the mystery of how these fields form in the first place. One theory points to the dynamo effect, spinning clouds of charged particles generating magnetic energy, much like Earth's core creates our planet's magnetic field. But in galactic tornadoes, the scale is unimaginable. Turbulent gas swirling at near light speeds, twists these fields into knots, storing energy until it erupts in bursts of cosmic lightning. Some astronomers compare it to winding up a rubber band until it snaps, releasing all that pent-up force in an instant. When that happens, anything nearby planets, asteroids, even light itself gets caught in the crossfire. Yet for all their destructive potential, magnetic fields might also be the universe's way of imposing order on chaos. Without them, the energy of a galactic tornado would dissipate in all directions, like an explosion in zero gravity. Instead, these fields focus the storm, directing its fury along precise paths. That focus could explain why some planets are utterly obliterated while others, just light years away, are merely nudged out of orbit. It's a cosmic game of chance, where the invisible lines of magnetic force decide which worlds survive and which are torn apart. And here's the most tantalizing possibility. What if these fields don't just protect planets? What if they preserve them? A rogue planet stripped of its star and adrift in the void might seem doomed to freeze, but if it carries a strong magnetic field of its own, that field could act like a shield, trapping residual heat and deflecting deadly cosmic rays. Deep beneath its icy surface, geothermal activity or tidal forces might keep oceans liquid, creating a refuge for any hardy life that once called that world home. We've seen hints of this on Jupiter's moon Europa, where a magnetic field interacts with its subsurface ocean, generating currents that could sustain microbial life. Now picture that scenario playing out on a rogue planet, its magnetic field the only thing standing between it and the utter blackness of space. The more we learn about these invisible forces, the clearer it becomes. Magnetic fields aren't just side players in the drama of galactic tornadoes. They're conductors choreographing the storm's violence while occasionally offering a lifeline to the worlds caught in its grip. And somewhere in the darkness, right now, a planet might owe its survival to these unseen threads, a whisper of order in the chaos, written in the language of magnetism. The hunt for rogue planets isn't just about ticking boxes in a cosmic census, it's a forensic investigation into the universe's most violent storms. Every exiled world astronomers spot is a piece of evidence, a silent witness to the chaos that once tore it from its home. Take the recent discovery of a rogue planet roughly the size of Earth, drifting alone just a few dozen light-years away. At first glance, it might seem like a curiosity, a frozen relic with no star to warm it. But to scientists, it's a Rosetta Stone, a clue that could decode how galactic tornadoes sculpt entire solar systems. Detecting these wanderers is like finding needles in a galaxy-sized haystack, but new technologies are turning the impossible into routine. The Nancy Grace Roman Space Telescope, set to launch in the next few years, is designed to scan the skies with unprecedented precision, hunting for the faint infrared glow of rogue planets. Unlike traditional telescopes that rely on starlight, Roman will spot these worlds by their residual heat, thermal fingerprints left over from their violent births. It's like using night vision goggles to spot a cooling ember in a dark forest. And with estimates suggesting there could be billions of rogue planets in our galaxy alone, Roman might soon flood astronomers with more data than they ever dreamed possible. But the real breakthroughs come when we study these worlds up close, or as close as we can get. Take the case of a rogue planet called SIMP J0. 1365663 plus 09344703, a mouthful of a name for a world with a stunning secret. Despite being adrift in space, it boasts a magnetic field 200 times stronger than Jupiter's, generating shimmering auroras without a star to fuel them. How the answer might lie in its tumultuous past. This planet could have been flung away so violently that its core was superheated, turning it into a dynamo of magnetic energy. It's a reminder that these exiles aren't just dead rocks, they're dynamic worlds with stories etched into their very structure. Yet the biggest question remains, where did they all come from? Some rogue planets might be orphans, born in gas clouds too sparse to ignite a star. Others could be the survivors of galactic tornadoes, cast adrift when their solar systems were torn apart. The key to solving this mystery lies in their diversity. By cataloging their sizes, compositions, and trajectories, astronomers are piecing together a map of cosmic destruction, a way to trace which planets were ripped from mature systems and which never knew a sun's warmth at all. And then there's the tantalizing possibility that some of these worlds weren't exiled by chaos but escaped it. Imagine a planet orbiting a star on the outskirts of a galaxy. When a galactic tornado strikes, the star might be torn away while the planet, through sheer luck, gets slingshotted in the opposite direction, a cosmic Hail Mary that saves it from annihilation. These survivors could be time capsules, preserving conditions from before the storm in their icy crusts or hidden oceans. Every new rogue planet discovered is another stitch in the tapestry of our galaxy's history. They're more than just celestial drifters, they're messengers from the universe's most violent moments, carrying secrets about how galaxies evolve, how planetary systems die, and perhaps even how life, against all odds, might find a way to endure. The hunt isn't just about finding them, it's about listening to what they have to say. 4 billion years from now, the night sky as we know it will vanish, not in a blink, but in a slow-motion cataclysm that reshapes our galaxy forever. The Andromeda Galaxy, that faint smudge of light visible on clear nights, is hurtling toward us at over 110 kilometers per second. When it arrives, the collision won't just rearrange stars, it could unleash forces eerily similar to the galactic tornadoes we've been exploring. Picture two titanic spirals of stars, gas, and dark matter tangling in a gravitational dance. They're supermassive black holes spiraling toward each other, churning spacetime into whirlpools of chaos. The Milky Way, as we know it will cease to exist, merged into a new hybrid galaxy astronomers poetically call Milkdromeda. But what does this mean for Earth? Will our planet be flung into the void like those rogue worlds we've discussed? The truth is, no one knows for sure, but the odds might surprise you. Our solar system sits about 27,000 light-years from the galactic center, far from the maelstrom where the black holes will eventually merge. That distance could be our saving grace. Simulations suggest the actual collision between stars is unlikely. Space is so vast that most will pass right by each other like ships in the night. The real danger lies in the aftermath, when gravitational shockwaves from the merging black holes ripple outward, potentially destabilizing orbits across the galaxy. Here's where things get unpredictable. Earth's fate hinges on a cosmic coin toss. If our solar system gets caught in a gravitational eddy, a miniature version of those galactic tornadoes, it could be nudged into a new, erratic orbit or even ejected entirely. But there's a flip side. We might also be slingshotted closer to the galactic core, where the density of stars and radiation would fry our planet's surface. Or in a best-case scenario, we'd sail through unscathed, our orbit barely disturbed while the cosmos rewrites itself around us, the wild card, our sun. By the time Andromeda arrives, our star will already be nearing the end of its life, swelling into a red giant that might engulf Earth long before galactic chaos has its say. But let's say humanity, or whatever we've evolved into, finds a way to survive. The view from Earth during the merger would be nothing short of apocalyptic beauty. Over millions of years, Andromeda would grow from a faint smudge to a glittering band stretching across the sky, its stars mingling with ours in a celestial ballet. Then, as the black holes at the heart of both galaxies finally merge, the sky would erupt in gravitational fireworks, space-time itself ringing like a bell as the universe's most violent forces shake the heavens. Yet amid this chaos, there's a strange silver lining. Galactic collisions aren't just destructive, they're creative. The shockwaves from the merger would trigger bursts of star formation, seeding Milky with new worlds and possibly new chances for life. The raw materials of our solar system, the carbon in our bones, the oxygen in our air, were forged in similar cataclysms billions of years ago. In a way, we're the children of chaos, and so might be whatever comes after us. So while the collision with Andromeda sounds like an ending, it's really a transformation, one last great reshuffling of the cosmic deck. Whether Earth survives the storm or becomes another rogue planet drifting through the void, one thing's certain: the universe never stops reinventing itself. And somewhere in that distant future, a new generation of astronomers might gaze up at a sky we'd barely recognize, tracing their origins back to the moment two galaxies became one. To grasp the sheer ferocity of a galactic tornado, you have to step into the mind-bending realm of Einstein's relativity, where gravity isn't just a force, but a warp in the very fabric of spacetime itself. Picture a trampoline stretched taut with a bowling ball sunk into its center. That's how mass distorts spacetime. The heavier the object, the deeper the dent, and the stronger its gravitational pull. Now imagine that trampoline caught in a hurricane, its surface twisting into spirals so violent they send marbles, or in this case, planets, careening off into the darkness. That's the essence of what's happening in these cosmic storms. The supermassive black holes at the heart of galactic tornadoes don't just bend spacetime, they shred it, creating whirlpools of distorted reality where the usual rules of physics start to unravel. Take frame dragging, for example. As a black hole spins, it doesn't just pull matter inward, it tugs spacetime along with it, like a spoon swirling in honey. Near the event horizon, this effect becomes so extreme that spacetime itself is dragged into a frenzied whirlpool. Anything caught in this current, whether gas, stars, or planets, is forced into orbit at speeds approaching light. But here's where relativity throws us a curveball. Time doesn't pass at the same rate for everyone. To an outside observer, a planet spiraling toward the tornado's core would appear to slow down, its light reddening as gravity stretches time like taffy. For the planet itself, seconds might feel like normal, even as centuries pass elsewhere in the universe. It's a paradox that challenges our very perception of reality. Then there's the phenomenon of tidal disruption. In everyday life, tides are gentle, the moon's gravity tugging on Earth's oceans. But in the grip of a galactic tornado, tidal forces become cosmic meat grinders. A planet venturing too close to the storm's core would experience gravity's pull so unevenly that the side facing the black hole is stretched violently while the opposite side is compressed. The result, spaghettification, a whimsical term for a gruesome fate. The planet isn't just torn apart, it's unraveled into a stream of molten debris, its remains swirling into the black hole's accretion disk like salt tossed into a whirlpool. Yet even these nightmarish conditions can't quite explain some of the bizarre behaviors we've observed. Take the case of floating orbits, paths where planets seem to defy the storm's chaos, locked in stable loops despite the surrounding mayhem. Relativity offers a clue. These orbits might exist in regions where spacetime's warping creates gravitational valleys, pockets where a planet can roll endlessly like a marble in a bowl. It's as if the tornado carves its own rules, offering fleeting sanctuaries amid the chaos. The real frontier, though, lies in the uncharted territory where relativity meets quantum mechanics. Near the singularity of a black hole, spacetime curves so sharply that the laws of physics as we know them break down. matter is crushed to infinite density, time ceases to have meaning, and the very concept of here and now dissolves. Galactic tornadoes thrust us toward this edge of understanding, where our theories flicker like candles in a hurricane. They're not just cosmic oddities, they're laboratories for the most extreme physics imaginable, testing whether relativity's equations hold up or if something even stranger awaits discovery. So while we marvel at the spectacle of these storms, remember, they're more than just destructive forces. They're cosmic teachers, revealing the hidden contours of spacetime in ways no textbook ever could. And with each observation, we're not just watching the universe, we're decoding its deepest secrets, one warp at a time. Neutron stars are the universe's ultimate wrecking balls, city-sized remnants of dead stars, packing more mass than our sun into a sphere no wider than Manhattan. Born from the explosive deaths of massive stars, these ultra-dense objects don't just drift passively through galactic tornadoes. They amplify the chaos, turning an already violent storm into a gravitational free-for-all. Picture a bullet fired into a whirlwind. Now replace the bullet with a neutron star, spinning hundreds of times per second and trailing a wake of warped space-time. That's the kind of havoc these objects unleash when caught in the storm's grip. When a galactic tornado rages, neutron stars don't just get swept along. They become gravitational anchors, pulling nearby matter and even other stars into their orbit. Their immense density creates gravity wells so steep that passing planets or debris can be yanked off course, adding another layer of unpredictability to the storm's fury. But the real spectacle begins when two neutron stars spiral toward each other, locked in a death spiral by the tornado's turbulent currents. As they collide, the impact isn't just a flash in the cosmic dark, it's a kilonova, an explosion so bright it outshines entire galaxies for days. The energy released in that moment is enough to forge gold, platinum, and other heavy elements in its wake, scattering them across the cosmos like cosmic confetti. What makes these collisions especially wild is their aftermath. Instead of a black hole, some merging neutron stars might collapse into a hypermassive neutron star, a fleeting, unstable beast that spins faster than a blender on its highest setting before finally imploding. Others could eject magnetized jets of material at near light speed, creating shockwaves that ripple through the surrounding gas and dust. These shockwaves can trigger chain reactions, compressing nearby clouds and sparking the birth of new stars, proof that even in destruction, the universe seeds new beginnings. But here's the twist: not all neutron stars in a galactic tornado meet a fiery end. Some get flung outward like cosmic slingshots, ejected at velocities so high they escape their galaxy entirely. These rogue neutron stars, known as runaway pulsars, streak through intergalactic space like lone wolves, their beams of radiation cutting through the darkness like lighthouse beams in an endless ocean. And if one happened to pass near a rogue planet, its intense magnetic field could bathe that frozen world in enough radiation to light up its skies with auroras brighter than any northern lights we've seen on Earth. The more we learn about neutron stars in these extreme environments, the clearer it becomes. They're not just bystanders in galactic tornadoes, they're catalysts turning chaos into spectacle and destruction into creation. Every kilonova, every runaway pulsar, every ripple in spacetime they leave behind is a reminder that even the universe's most violent storms have a strange, almost poetic way of leaving something extraordinary in their wake. The speed of a galactic tornado isn't just fast, it's unthinkable. These storms don't spin at thousands of kilometers per hour like earthly hurricanes. They whirl at a significant fraction of the speed of light, turning entire regions of space into cosmic centrifuges where the laws of physics are pushed to their limits. Picture the fastest thing you can imagine, a bullet, a rocket, even a beam of light itself, and then realize these tornadoes could outpace them all, their outer edges whipping around at velocities that defy human intuition. What fuels such mind-bending speed? It all comes down to the sheer gravitational muscle at play. At the heart of these storms, supermassive black holes act like cosmic engines, their immense pull accelerating nearby matter to relativistic speeds. Gas, dust, and even entire star systems get caught in this vortex, dragged along like leaves in a whirlwind. But here's the twist: it's not just the black hole's gravity doing the work. The tornado's own rotation creates a feedback loop, a self-reinforcing cycle where each spin tightens the storm's grip, funneling more energy into the system and ratcheting up the speed even further. It's like a runaway train where the tracks keep getting steeper and the brakes don't exist. The consequences of this velocity are staggering. At these speeds, time itself begins to warp. Thanks to Einstein's relativity, clocks near the tornado's core would tick noticeably slower than those in calmer regions of space. A planet caught in the outer bands might experience centuries while its inner counterparts endure millennia, a temporal rift that could stretch civilizations to their breaking points. Even more bizarrely, the tornado's rotation can twist spacetime into knots, creating regions where the very concept of forward becomes meaningless. Light bends into spirals, and particles accelerated to near-light speeds slam into each other with enough force to spark fleeting bursts of antimatter. But the real jaw-dropper: this speed is what gives the tornado its planet-flinging power. When an object, whether a star, a gas cloud, or a hapless planet, gets caught in the storm, it's not just pushed. It's catapulted. The rotational energy transfers into the object, hurling it outward like a stone from a slingshot. Some planets might be ejected at velocities so high they escape their galaxy entirely, destined to drift through the intergalactic void for eternity. Others could be spun into bizarre, hyper-elongated orbits, tracing figure eights around multiple stars or even black holes. Yet for all their destructive potential, these speeds also hint at something profound: the universe's ability to turn chaos into precision. The same forces that exile planets can also sculpt entire star systems, carving out stable orbits amid the storm's fury. It's a reminder that even the most violent phenomena obey an underlying order, one we're only beginning to decode. So the next time you hear about a rogue planet adrift in the darkness, remember, its journey began with a spin so fast, so fierce, it defies everything we know about speed itself. When the fury of a galactic tornado finally subsides, the universe doesn't just hit pause, it leaves behind a scarred, reshaped reality where nothing orbits as it once did. Imagine walking through a forest after a hurricane, trees uprooted, rivers rerouted, the very landscape unrecognizable. Now scale that up to galactic proportions, where entire star systems have been tossed like dice across the cosmic table. The planets that weren't flung into the void now cling to precarious new paths, some looping erratically around multiple stars, others trapped in gravitational tug-of-wars between black holes and surviving giants. These aren't the neat, circular orbits we're used to, their chaotic, elongated, or even figure-eight trajectories that defy textbook astronomy. Take binary star systems, for example. Normally, these stellar pairs waltz gracefully around a shared center of gravity, but in the wake of a galactic tornado, that dance can turn into a destabilized free-for-all. A planet once comfortably orbiting one star might find itself yanked between both, its climate swinging between blistering heat and frozen darkness as it oscillates between hosts. Some worlds end up so far from their new stars that their atmospheres collapse into icy shells, while others are dragged so close they're baked into barren wastelands. The survivors of these storms don't just adapt, they endure conditions that rewrite the rules of planetary science. Then there are the stars themselves, flung into orbits that defy the galaxy's natural flow. Astronomers call these hypervelocity stars, and they're the celestial equivalent of shrapnel from an explosion. A star that once traced a lazy spiral around the galactic core might now be racing outward at millions of kilometers per hour, destined to escape the galaxy entirely. Others get trapped in chaotic clusters, their movements so unpredictable they resemble swarms of bees rather than the orderly stellar neighborhoods we're familiar with. Over time, gravity might smooth out some of this chaos, but the scars remain subtle wrinkles in the galaxy's structure that hint at ancient violence. But the most haunting remnants aren't the stars or planets, it's the ghosts, vast clouds of ionized gas glowing faintly from the energy of long-past collisions, drift through the tornado's aftermath like cosmic fog. These nebulae are littered with the debris of shattered worlds, fragments of molten rock, twisted metal from planetary cores, and the faint chemical signatures of vaporized atmospheres. Some of this wreckage might eventually coalesce into new worlds, but for now, it's a graveyard of what once was a silent testament to the storm's power. Yet amid the chaos, there's an unexpected silver lining. Galactic tornadoes don't just destroy, they redistribute. The same forces that tear planets from their stars also scatter heavy elements forged in stellar furnaces, seeding the galaxy with the building blocks for new solar systems. The gold in your jewelry, the uranium in nuclear reactors, even the calcium in your bones, these elements might have been forged in the aftermath of such cataclysms, their atoms flung across light years until they found their way into planets like Earth. So when we look at a galaxy reshaped by one of these storms, we're not just seeing destruction. We're witnessing a rebirth, a cosmic reset that paves the way for new stars, new worlds, and perhaps even new life. The universe never truly loses what these tornadoes take, it just rearranges the pieces into something we're only beginning to understand. Cosmic dust might seem like a mere afterthought in the grand theater of galactic tornadoes, tiny specks floating in the void, too small to matter. But don't be fooled. These microscopic grains, some no larger than a virus, play a role far more dramatic than their size suggests. Picture a storm raging across a desert where every grain of sand becomes a weapon, whipped into a frenzy by the wind. Now replace the desert with an entire galaxy, and the sand with trillions of dust particles, each one a potential catalyst for chaos, or an unexpected shield against destruction. In some cases, cosmic dust acts as a cosmic sponge, soaking up the tornado's fury. These dense clouds, often lingering between stars, can absorb and scatter the storm's intense radiation, softening its impact on nearby planets. It's like throwing a thick blanket over a bonfire. The flames might still burn, but their reach is muted. Observations of active galaxies show that regions shrouded in dust often experience less extreme heating, their atmospheres spared from being stripped away by the tornado's wrath. For a planet on the edge of the storm, this could mean the difference between annihilation and survival, a thin veil of dust standing between it and oblivion. But there's a flip side. When a galactic tornado rips through a dust cloud, it doesn't just disperse it, it weaponizes it. Those tiny particles, accelerated to blistering speeds, become celestial buckshot, pelting everything in their path. A single grain might seem harmless, but at velocities approaching a fraction of the speed of light, it carries enough kinetic energy to punch through solid rock. Multiply that by billions, and you've got a sandblaster of cosmic proportions, scouring the surfaces of planets, eroding atmospheres, and even chipping away at moons over millennia. The damage isn't always immediate, but it's relentless, a slow, grinding erosion that leaves worlds barren and pockmarked. The strangest twist, some of this dust might actually be the remains of planets caught in previous storms. When worlds are torn apart, their shattered crusts and vaporized atmospheres condense into new dust grains, laced with metals and minerals forged in the heart of the chaos. These recycled particles then join the storm's arsenal, a macabre feedback loop where destruction begets more destruction. It's as if the tornado feeds on its own aftermath, growing stronger with each cycle of violence. Yet amid this bleak cycle, there's a glimmer of cosmic irony. The same dust that fuels destruction might also sow the seeds of rebirth. Heavy elements like carbon, silicon, and iron, essential building blocks for new planets, are forged in the hearts of stars and scattered by these storms. Over eons, dust clouds enriched by galactic tornadoes could collapse under their own gravity, forming new star systems with planets far richer in resources than their predecessors. In a way, these tiny grains are both the aftermath of apocalypse and the raw materials for a fresh start, proof that even the universe's most violent acts are part of a larger, ever-turning wheel. So the next time you gaze up at the Milky Way's hazy band of light, remember, what looks like a serene tapestry of stars is actually a dynamic, dusty battleground. Those faint clouds aren't just decoration, they're active players in the galaxy's story, shaping the fate of worlds caught in the storm's path. And somewhere out there, right now, a single speck of dust might be deciding whether a planet lives or dies. Could life cling to existence on a rogue planet, adrift in the eternal night of interstellar space? At first glance, the idea seems absurd. A world without sunlight, where temperatures hover just above absolute zero, and the only heat comes from the feeble glow of radioactive decay deep in its core. But Earth has taught us that life is stubborn, thriving in places we once thought uninhabitable. Scalding volcanic vents, acidic hot springs, even the crushing depths of the ocean floor. If microbes can survive there, why not in the frozen ruins of an exiled world? Consider the case of tardigrades, microscopic creatures so resilient they've survived the vacuum of space. In 2007, scientists launched these water bears into orbit, exposing them to cosmic radiation and extreme cold. Not only did they endure, they reproduced. Now imagine a rogue planet with subsurface oceans, kept liquid by tidal forces or geothermal activity. Even without sunlight, chemosynthetic organisms could draw energy from hydrothermal vents, just as they do in Earth's darkest oceans. The planet's icy crust might act as a natural radiation shield, protecting any life beneath from the harshness of space. It's not a tropical paradise, but for extremophiles, it could be enough. Then there's the wild card, magnetic fields. Some rogue planets, particularly gas giants ejected early in their star system's history, might retain strong magnetic shields. These invisible barriers could deflect deadly cosmic rays, preserving an atmosphere, or at least pockets of it, beneath layers of ice. Even a thin atmosphere, trapped against the surface by gravity, might create pressure and insulation enough for liquid water in subsurface niches. And where there's liquid water, as we've learned, the possibility of life can never be ruled out. The real game changer, though, might be time. A rogue planet isn't on some countdown clock. It could drift for billions of years, its internal heat fading slowly, giving any potential life forms an almost unimaginable span to adapt. Evolution works in strange ways given enough millennia. Who's to say what kind of biochemistries could emerge in the perpetual dark? We've already found bacteria thriving in nuclear waste and microbes that breathe metals instead of oxygen. The rules of life, it seems, are far more flexible than we once believed. Of course, the odds are stacked against it. Radiation, freezing temperatures, and the lack of an energy source like sunlight make rogue planets some of the most hostile environments imaginable. But if there's one lesson from Earth's extremophiles, it's that life doesn't play by our expectations. It finds a way, often in the last places we'd think to look. So while a rogue planet might seem like a frozen tomb, it could also be a time capsule, a silent ark carrying the seeds of life across the galaxy, waiting for the universe to give it another chance. Galactic tornadoes aren't just the stuff of astrophysics. They've stormed their way into our stories, becoming a staple of science fiction that blends awe with adrenaline. Take Interstellar, where the black hole Gargantua warps spacetime into a swirling maelstrom, its accretion disk glowing like a cosmic hurricane. While the film took creative liberties, it nailed the essence of these phenomena: overwhelming scale, gravitational chaos, and the eerie beauty of destruction. Christopher Nolan's team even consulted physicist Kip Thorne to ensure the visuals respected relativity, giving audiences a glimpse of what a real spacetime whirlpool might look like: spiraling light, distorted perspectives, and time bending under the storm's grip. Then there's Star Wars, where the Maw cluster near Kessel isn't just a navigational hazard, it's a gravitational nightmare. Black holes and supernova remnants churn together, creating a labyrinth of death that Han Solo famously threads in the Millennium Falcon. The scene plays fast and loose with physics, but it captures the visceral terror of these storms. One wrong move, and you're spaghetti-fied or lost forever. It's storytelling at its most primal, turning cosmic violence into a trial by fire for heroes. But fiction doesn't always lean into spectacle. In Arthur C. Clarke's The Songs of Distant Earth, a rogue planet flung from its system by galactic upheaval becomes a refuge for humanity, a frozen ark carrying the last survivors of Earth. Here, the tornado's aftermath isn't just destruction, it's a catalyst for rebirth, a theme that echoes real theories about exiled worlds harboring life. Clarke's genius was in flipping the script, asking not just how these storms kill, but how they might save. Even horror gets in on the action. Event Horizon imagines a ship torn apart by a man-made black hole, its crew subjected to hallucinations and dimensional rifts, a galactic tornado's psychological toll made literal. The film's hellish visuals tap into something deeper: the fear of the unknown, the dread of forces so vast they unravel sanity. It's a reminder that these storms aren't just physical threats, they're existential ones, challenging our place in a universe indifferent to our survival. What ties these depictions together is their duality: galactic tornadoes as both destroyers and creators, obstacles and opportunities. Whether it's the psychedelic vortex of Doctor Who's time storms or the apocalyptic tides in the three-body problem, storytellers keep returning to these phenomena because they embody the ultimate conflict: humanity versus the cosmos. And in that struggle, whether we're Han Solo outrunning the Maw or Clarke's colonists adapting to a frozen exile, the real question isn't just how we survive. It's what we become in the storm's shadow. To grasp the staggering energy output of a galactic tornado, you'd need to stack 100 supernova together, and even that might not be enough. These cosmic storms don't just release energy, they weaponize it, channeling the equivalent of a star's lifetime radiation into a maelstrom that can rage for millions of years. The numbers defy comprehension. A single galactic tornado can unleash enough power in 1 second to outshine every star in the Milky Way combined. That's not an explosion, it's a sustained eruption, a celestial blowtorch searing across the cosmos. Where does all this energy come from? The answer lies in the tornado's gravitational engine. Supermassive black holes, those bottomless pits of spacetime, don't just swallow matter, they shred it. As gas, dust, and even stars spiral toward the event horizon, friction heats them to billions of degrees, transforming them into plasma so energetic it glows across the electromagnetic spectrum. But here's the twist, not everything falls in. Magnetic fields whip this superheated material into jets and outflows, launching it back into space at nearly light speed. It's like a cosmic recycling plant where matter isn't destroyed. It's reforged into pure energy, then blasted outward to fuel the storm. The scale of this process is what sets galactic tornadoes apart. While a supernova might light up the sky for weeks, these storms burn brighter than entire galaxies for epochs. Take the famous quasar Ton 618. Its accretion disk alone radiates with the luminosity of 2 trillion suns. That's not just bright, it's a physical impossibility by normal stellar standards. The only way to achieve such output is through the extreme physics of a black hole's maw, where gravity's grip twists matter into energy factories of unimaginable efficiency. Yet raw luminosity is only half the story. Galactic tornadoes don't just emit light, they sculpt it. Polarized radiation beams spiral through magnetic vortices, creating patterns astronomers use to map the storm's structure. X-rays reveal shock waves where jets slam into interstellar gas, while infrared traces the glow of dust clouds heated to incandescence. Each wavelength is a breadcrumb leading back to the tornado's heart, showing how energy transforms as it ripples outward. The most mind-bending consequence, this energy doesn't just dissipate, it travels, crossing intergalactic space to influence regions far beyond the storm's immediate reach. Some theorists suggest these outflows could trigger star formation in distant galaxies, like a cosmic domino effect where destruction in one place sparks creation in another. It's a reminder that in the universe's economy, nothing is wasted, not even the fury of a galactic tornado. Energy, matter, even the fabric of spacetime itself are all threads in a single, unbroken web. And when one thread trembles with the force of a storm, the whole cosmos feels the vibration. At the heart of every galactic tornado, where spacetime twists into knots and matter is shredded beyond recognition, there's a frontier where our understanding of physics starts to unravel, the quantum realm. We're used to thinking of these cosmic storms in terms of gravity and relativity, but at their most extreme scales, the rules change. Particles caught in the maelstrom don't just behave like billiard balls colliding. They flicker in and out of existence, tunnel through impossible barriers, and entangle across light years in ways that defy classical intuition. This isn't just chaos, it's quantum chaos, where the very fabric of reality blurs at the edges. Take Hawking radiation, the eerie glow predicted to emanate from black holes due to quantum fluctuations near the event horizon. In the swirling heart of a galactic tornado, this effect could be amplified to staggering proportions. Virtual particle pairs, which normally annihilate each other instantly, might get torn apart by the storm's gravitational shear, with one particle swallowed by the black hole and the other ejected as real radiation. Over time, this process could strip energy from the tornado itself, slowly weakening its fury. It's a paradox. The same quantum effects that seem insignificant on human scales could become cosmic stabilizers, acting as a hidden thermostat for the universe's most violent storms. Then there's quantum tunneling, the bizarre phenomenon where particles bypass energy barriers as if they were ghosts walking through walls. In the accretion disks of galactic tornadoes, where temperatures and pressures reach unimaginable extremes, this tunneling might allow nuclear reactions to occur at rates far beyond what classical physics predicts. Hydrogen atoms could fuse into helium without the usual stellar furnaces, creating pockets of energy that flare unpredictably like cosmic fireworks. These quantum-fueled reactions could explain some of the bizarre, short-lived bursts of radiation astronomers detect near active black holes. Flares that flicker in and out of existence faster than traditional models can account for. But the real wild card, quantum entanglement, Imagine two particles born in the tornado's chaos, linked so intrinsically that changing one instantly affects the other, no matter how far apart they drift. Now scale that up, entire clouds of ionized gas entangled across light years, their fates intertwined by the storm's violence. If one cloud is ejected at near light speed, its entangled partner might exhibit strange, correlated behavior, like spinning in perfect sync despite being on opposite sides of the galaxy. This isn't just theoretical. Recent observations of polarized light from quasars hint at large-scale quantum coherence, as if the universe itself is performing an intricate dance we're only beginning to decode. The implications are staggering. If quantum effects can influence something as vast as a galactic tornado, they might also hold clues to taming its chaos. Hypothetical technologies far beyond our current grasp could one day harness these phenomena, using entanglement to transmit information across cosmic distances or tapping into zero-point energy hidden in the quantum foam. For now, these ideas live in the realm of speculation, but they underscore a profound truth. The universe's smallest rules might govern its grandest storms. So the next time you picture a galactic tornado, remember, it's not just a whirlpool of stars and gas. It's a quantum engine where the invisible flicker of particles shapes the destiny of entire worlds. And somewhere in that chaos, the universe is playing a game far stranger and far more beautiful than we ever imagined. Dark energy, the universe's most enigmatic force, doesn't just push galaxies apart. It might also be the silent architect behind some of the cosmos' most violent storms. Imagine a phantom hand tugging at the fabric of spacetime, not just expanding the universe but twisting its very structure in ways we're only beginning to comprehend. Galactic tornadoes, already fueled by supermassive black holes and colliding galaxies, could be caught in this invisible current, their fury amplified by the same mysterious energy driving the cosmos to accelerate apart. Here's the startling possibility: dark energy might not be uniform. Some theories suggest it could pool in certain regions of spacetime like invisible whirlpools, creating pockets where its repulsive gravity is stronger. If a galactic tornado forms near one of these knots, the effect could be catastrophic. Normal matter and energy already warp spacetime, but add dark energies push to the mix, and the storm's expansion could spiral out of control. Picture a hurricane fed by an unseen jet stream, growing larger and more violent with forces we can't directly observe. The math behind this is mind-bending. Dark energy's influence is usually calculated on cosmic scales, its effects noticeable only across billions of light years. But if it interacts with the extreme gravity near supermassive black holes, even minute fluctuations could tip the balance. Simulations show that in regions where dark energy density varies, spacetime doesn't just stretch, it vibrates, creating ripples that could resonate with a black hole's spin. The result, a feedback loop where the tornado's rotation pumps energy into the surrounding dark field, which in turn accelerates the storm's growth. Yet the most tantalizing clue comes from the universe's largest structures. Vast cosmic voids, regions nearly empty of galaxies, seem to expand faster than predicted, as if dark energy is more concentrated there. If galactic tornadoes tend to form near the edges of these voids, their evolution might carry fingerprints of that interaction. Astronomers have already spotted a few hyperactive storms in these borderlands, their outflows stretching farther and faster than models can explain. Coincidence or evidence of dark energy's invisible hand? The implications don't stop there. If dark energy can shape these tornadoes, the reverse might also be true. The matter and energy churned up by the storms could perturb the local dark energy field, creating subtle distortions that ripple across spacetime. It's a two-way street. the universe's expansion influences the storms, and the storms, in turn, might leave scars on the cosmos' expansion. This isn't just theoretical. Upcoming telescopes like the Vera Rubin Observatory and the Euclid Space Mission are designed to map dark energy's distribution with unprecedented precision. By comparing the locations of galactic tornadoes to these maps, scientists might finally catch the phantom force in the act, revealing whether it's a passive backdrop or an active player in the universe's most violent dramas. What's at stake isn't just understanding these storms. It's decoding the universe's hidden syntax, the secret dialogue between visible chaos and invisible energy that shapes everything from the smallest planet to the fate of the cosmos itself. Every galactic tornado we study could be a message in a bottle, carrying clues to the greatest mystery of all: why the universe refuses to sit still. Time doesn't just pass near the heart of a galactic tornado. It warps, twists, and grinds to a crawl under the crushing weight of gravity's grip. Imagine standing on the surface of a planet caught in this cosmic whirlpool, where the very fabric of reality bends so drastically that a single minute for you could stretch into years for someone watching from afar. This isn't science fiction, it's Einstein's theory of relativity in action, pushed to its most extreme limits. The closer a world drifts to the storm's core, the more it becomes trapped in a gravitational slow motion where time itself becomes fluid. The mechanics behind this are as mind-bending as they are precise. At the tornado's heart, supermassive black holes spin spacetime into a vortex so tight that even light struggles to escape its pull. For a planet orbiting near this region, the black hole's gravity doesn't just tug at its surface, it stretches time like taffy. Clocks on that world would tick agonizingly slow compared to those in calmer regions of space. A decade for its inhabitants might pass in the blink of an eye for a distant observer. This phenomenon, known as gravitational time dilation, isn't just theoretical. We've measured it right here in our own solar system. GPS satellites orbiting Earth, where gravity is slightly weaker, have to correct for time discrepancies of microseconds every day, now scale that up to a black hole's influence, and the effect becomes staggering. A planet here wouldn't just experience time differently, it might witness the rise and fall of civilizations elsewhere in the galaxy, while its own history creeps forward in slow motion. But the real cosmic irony, this time warp isn't symmetrical. While the planet's surface languishes in gravitational molasses, the storm rages around it at full speed. Radiation, debris, and gravitational waves whip past at near-light velocity, creating a surreal disconnect between the world and its surroundings. Imagine watching a hurricane from inside an unbreakable bubble, where the storm's fury unfolds in fast-forward while you're trapped in a crawl. Any life clinging to existence on such a world would face a paradox. Their biology, bound by local time, might age at a glacial pace while the universe outside races ahead. A human explorer landing there could return to their ship only to find their crew long dead, their home planet unrecognizable after centuries of progress. Yet time dilation isn't just a one-way ticket to isolation. It might also serve as a perverse sanctuary. A planet teetering on the edge of the storm's event horizon could survive far longer than its counterparts flung into the void. While the rest of its star system is shredded or scattered, this world persists in its time bubble, preserved like a fossil in amber. Civilizations here might develop entirely unique cultures, their slow perception of time allowing them to observe cosmic events, supernova, galactic collisions, even the birth of new stars as fleeting spectacles rather than epoch-spanning phenomena. Their astronomy would be unlike anything we can imagine, their philosophy shaped by the certainty that the universe beyond their world moves at a breakneck pace they'll never experience. The most haunting question, though, is what happens when, or if, such a planet escapes, if a gravitational slingshot or passing star were to pull it free, time would snap back to normal like a released rubber band. Centuries of external history would suddenly catch up in a dizzying rush. Landscapes frozen for ages would erode in moments under sudden cosmic weathering. Any structures or life forms adapted to slow time would face catastrophic upheaval. It's a scenario that blurs the line between salvation and ruin, a world spared from the storm's wrath only to be thrust into a future it was never meant to see. This time-warping effect isn't just a curiosity, it's a laboratory for the universe's most fundamental laws. By studying how galactic tornadoes distort time, scientists can test relativity in conditions no Earth-based experiment could replicate. Each warped planet is a natural clock. Its slowed ticks a testament to gravity's power over reality itself. And somewhere out there, right now, a world might be drifting through this temporal twilight, its seconds stretching into eons, carrying secrets about time that we've only begun to unravel. Gravitational waves aren't just messengers from recent cosmic collisions. They could be faint echoes of ancient storms that raged billions of years ago. Imagine the universe as a vast recording device, where every cataclysmic event leaves behind a subtle vibration in space-time, a whisper of violence etched into the fabric of reality itself. Some of the faintest signals picked up by observatories like LIGO might not be from black holes merging yesterday, but from galactic tornadoes that tore through the cosmos when Earth was still molten rock. These aren't just ripples in space, they're ripples in time, carrying stories from an era when the universe was younger, denser, and far more chaotic. The key to decoding these whispers lies in their unique fingerprints. When two black holes collide today, the gravitational waves they produce have a clean, predictable pattern, a sharp chirp that rises in pitch before cutting off abruptly. But the waves from an ancient galactic tornado would tell a different story. Picture the aftermath of a stormy sea, where overlapping waves create complex interference patterns. A tornado's gravitational signature would be similarly messy, with multiple frequencies blending together as the event's violence rippled outward across eons. Some researchers believe they've already spotted these anomalies in LIGO data, strange, elongated signals that don't match any known cosmic merger. Could these be the faint echoes of a supermassive black hole's tantrum from 8 billion years ago, its gravitational waves finally reaching us after journeying across most of cosmic history? Here's where it gets even stranger. These ancient waves might not just be relics, they could be actively shaping the universe we see today. As gravitational ripples traverse the cosmos, they subtly stretch and compress everything in their path, including other gravitational waves. An echo from an old galactic tornado could warp newer signals, creating telltale distortions like a funhouse mirror reflecting a reflection. Astronomers call this gravitational lensing for waves, and it might explain why some detections appear slightly smeared or duplicated. The universe isn't just sending us messages, it's folding them into origami on their way to our detectors. The most tantalizing possibility, these echoes might help solve one of astronomy's biggest missing puzzles. Where are all the intermediate mass black holes? We've found small ones formed from dead stars and supermassive giants anchoring galaxies, but the middleweights thousands of times the sun's mass remain elusive. Galactic tornadoes could be the answer. If these storms regularly fling mid-sized black holes into the void, their gravitational wave signatures would be distinct from typical mergers. A few candidate events already hint at this, with waveforms suggesting black holes far larger than stellar remnants but smaller than galactic cores. Each detection could be a breadcrumb leading back to an ancient tempest that scattered these missing links across the cosmos. But listening to echoes this old isn't easy. The farther back we peer, the more the universe's expansion stretches gravitational waves, redshifting them into lower frequencies. It's like trying to hear a recording played at half speed with all the details blurred. Next-generation detectors like the Laser Interferometer Space Antenna LISA will be tuned to catch these deeper notes, scanning for whispers from the universe's most turbulent adolescents. What they find could rewrite our understanding of how galaxies evolved, not from serene cosmic drawings, but from the wreckage of storms so violent their tremors never fully faded. So the next time you hear about a gravitational wave discovery, listen closely. That signal might not just be a headline from today's universe. It could be a postcard from an ancient apocalypse, a reminder that even the mightiest storms never truly die. They just ripple onward, carrying their stories into eternity. Every rogue planet drifting through the void is more than just a cosmic castaway. It's a clue, a silent witness to the unseen chaos that shaped our galaxy. When astronomers spot one of these wandering worlds, they're not just adding to a catalogue of celestial oddities. They're piecing together a forensic record of galactic violence, decoding how often these planet-flinging tornadoes tear through star systems. The numbers alone tell a startling story. If billions of rogue planets really do roam the Milky Way, their sheer abundance suggests these storms aren't freak accidents. They're part of the universe's natural order, recurring events that have been reshaping galaxies since the dawn of time. Take the case of a rogue planet spotted in the TW Hydra Association, a young stellar group just 200 light-years away. Unlike most exiles, this world hasn't had time to drift far. Its trajectory hints it was ejected recently, perhaps within the last million years. That's a blink in cosmic terms, offering astronomers a rare snapshot of the expulsion process in action. By studying its speed and composition, scientists can reverse engineer the forces that launched it, like detectives reconstructing a crime scene from a single bullet's trajectory. Was it flung by a passing star's gravity or caught in the wake of a nearby black hole's tantrum? The answers could reveal how often young star systems experience such upheavals during their formative years. But rogue planets aren't just about destruction, they're also time capsules. A world exiled billions of years ago preserves conditions from its birth era, frozen in interstellar deep freeze. Its atmosphere, if it has one, might contain chemical relics from a time before Earth even existed. Some could even harbor isotopes or molecules long vanished from younger planets, offering a window into the early universe's composition. It's like finding a sealed letter from the cosmos's violent youth, its contents untouched by the nuclear furnaces of later generations of stars. The real game changer, though, is what these orphans tell us about galactic demographics. If most stars form in dense clusters where gravitational turmoil is common, then ejection events might be as routine as supernova, a standard phase in a solar system's life. That would mean our own orderly neighborhood with planets neatly orbiting the sun could be the exception rather than the rule. The universe might be teeming with far more nomad worlds than stable ones, drifting through the dark like ships without ports. Yet for all their mysteries, rogue planets also hint at cosmic resilience. Some simulations suggest these exiles might outnumber stars by 20 to 1, meaning the galaxy's true population of worlds is vastly larger than we ever imagined. Even in chaos, the universe seems determined to create scattering planets like seeds, some of which might someday find new homes under alien suns. Each discovery doesn't just solve a puzzle. It rewrites the story of how galaxies grow, evolve, and occasionally shake loose their own building blocks into the void. For all our telescopes, simulations, and equations, galactic tornadoes still guard secrets that defy even the most brilliant minds. These aren't just gaps in our knowledge, they're chasms reminding us that the cosmos operates on scales and by rules we're only beginning to glimpse. Consider something as fundamental as predicting their formation. We know colliding galaxies and feasting black holes can spawn these storms, but why do some mergers trigger continent-sized tempests while others fizzle into calm? The variables at play, dark matter halos, magnetic field geometry, even quantum fluctuations near event horizons, create a puzzle with too many moving parts for our current models to solve. Take the enigma of angular momentum. In earthly tornadoes, rotation builds from wind shear and updrafts, mechanics we can replicate in labs, but scale that up to galactic proportions and the math breaks down. The spin of these cosmic vortices often exceeds what traditional fluid dynamics predicts, as if some hidden hand is cranking the storm's engine beyond natural limits. Some theorists point to dark matter's gravitational torque, others to spacetime itself twisting like a wrung towel near the black hole's pole. The truth: we're still chasing shadows, building theories on the fragile scaffolding of incomplete data. Then there's the mystery of missing precursors. Before a hurricane forms, satellites spot clusters of thunderstorms organizing into a spiral. Galactic tornadoes offer no such warning. By the time we detect one, it's often already in full fury, its origins shrouded in the observational equivalent of fog. The James Webb Space Telescope recently caught what might be a proto-tornado in a distant galaxy, a flickering region where gas clouds showed abnormal turbulence. But whether this is truly a storm in infancy or just cosmic background noise remains hotly debated. Without a reliable way to spot these monsters in their cradle, we're left reacting to their aftermath rather than understanding their birth. Perhaps most humbling is the energy accounting problem. When astronomers tally the power output of these storms, the light, heat, particle jets, and gravitational waves, the numbers never quite add up. There's always an energy surplus, an unaccounted for reservoir that suggests forces at work we haven't even identified yet. It's like watching a car speed past with no visible engine, leaving us to wonder what dark, exotic physics might be propelling it. Some speculate this missing energy ties into higher dimensional brain physics or vacuum energy fluctuations, realms where even our boldest theories tread lightly. Yet these unknowns aren't roadblocks, they're invitations. Each unsolved aspect of galactic tornadoes is a flashing signpost pointing toward deeper truths about how the universe operates. The very fact that they defy easy categorization, that they blend relativity, quantum effects, and thermodynamics into some transcendent new paradigm, suggests we're on the verge of discoveries that could reshape physics itself. Every time we hit the limits of our understanding, we're not failing, we're finding the universe's next set of instructions, written in a language we're still learning to read. The next decade of astronomy promises to peel back the veil on galactic tornadoes like never before, with a new generation of telescopes and detectors poised to capture these cosmic tempests in unprecedented detail. Imagine having front-row seats to a phenomenon we've only glimpsed through mathematical models and fleeting observations. That's the revolution coming to astrophysics. At the forefront is the Nancy Grace Roman Space Telescope, set to launch in 2027. Unlike Hubble's deep but narrow gaze, Roman will sweep vast swaths of sky with infrared vision perfect for spotting rogue planets ejected by ancient storms. Its wide-field camera could uncover thousands of these exiles in our galactic neighborhood alone, mapping their trajectories like forensic evidence pointing back to long-vanished tornadoes. Then there's the Laser Interferometer Space Antenna LISA, a trio of spacecraft that will form the first gravitational wave observatory in space. While ground-based detectors like LIGO catch the high-frequency chirps of stellar mass black holes colliding, LISA million-kilometer arms will sense the deep bass notes of supermassive black holes spiraling toward merger. These are the frequencies where galactic tornadoes sing, their gravitational waves carrying secrets about how spacetime twists during the most violent phases of the storm. LISA might even catch the moment when a spinning black hole's ergosphere, the region where space itself is dragged faster than light, becomes unstable, triggering outbursts that could fling planets across galaxies. But the real game changer might come from an unexpected direction: quantum sensors. Prototypes being tested now could one day detect the faintest ripples in spacetime or measure minuscule shifts in starlight caused by passing rogue planets. These devices exploit the bizarre properties of entangled particles to achieve sensitivities far beyond current technology. Picture arrays of these sensors orbiting Earth or stationed on the Moon, creating a web so precise it could spot a galactic tornado's gravitational fingerprint from billions of light years away. What makes this era especially thrilling is how these tools will work together. Roman's rogue planet sensors, combined with LISA gravitational wave maps and next-gen radio arrays like the Square Kilometer Array, will let scientists triangulate tornadoes across space and time. We might finally answer whether these storms cluster in certain galactic environments or if there's a hidden pattern to their occurrence. Some theorists even speculate we'll discover entirely new classes of spacetime vortices, perhaps remnants from the universe's first billion years, when conditions were ripe for hyperviolent black hole formation. The most profound revelations might come from what these storms leave behind. As we catalog more rogue planets, their compositions could reveal whether tornadoes preferentially eject certain types of worlds. Are gas giants more likely survivors than rocky planets? Do water-rich worlds get flung more easily due to ice's volatility under extreme forces? Each discovery will rewrite our understanding of planetary system evolution, showing that the cosmos doesn't just build worlds, it sometimes hurls them into the darkness to drift for eternity. This isn't just about satisfying scientific curiosity. Unraveling galactic tornadoes could reshape our cosmic perspective, revealing how often habitable planets get exiled and whether life might persist on these frozen nomads. As our telescopes peer deeper and our detectors grow more sensitive, we're not just observers of these storms, we're becoming witnesses to the universe's most spectacular acts of creation and destruction, unfolding on scales that still defy imagination. The age of cosmic storm chasing is just beginning. There's something profoundly unsettling yet awe-inspiring about a planet torn from its star and cast into the endless dark. It's not just a celestial eviction, it's a cosmic reckoning, forcing us to confront the fragility of existence itself. Think about Earth nestled comfortably in the Goldilocks zone, its orbit so stable we mark time by it. Now imagine that stability ripped away in an instant, our world hurled into the freezing void, untethered from the sun's warmth, its fate rewritten by forces beyond comprehension. This isn't science fiction, it's a reality for countless worlds, and it begs a haunting question. If the universe can exile entire planets without a second thought, what does that mean for us? These exiled worlds hold up a mirror to humanity's place in the cosmos. We like to think of our planet as a permanent stage, our civilizations the stars of the show. But galactic tornadoes remind us we're extras in a much grander production, one where the script can change without warning. Ancient philosophers once believed the heavens were unchanging, a perfect realm beyond Earth's messiness. Today, we know the universe is anything but static. It's a tempest of creation and destruction, where even planets are transient guests. The sheer randomness of it all is humbling. A rogue planet drifting through the void might have once harbored oceans, mountains, maybe even life, all erased by a gravitational fluke. It's a reminder that the universe doesn't discriminate. Chaos doesn't care about your atmosphere, your magnetic field, or your evolutionary milestones, yet there's a strange comfort in this cosmic indifference. If the universe has no grand plan, no destiny etched in starlight, then our existence, however precarious, is a triumph of chance. Every civilization that rises does so against astronomical odds, a spark of order in the chaos. Those exiled planets, they're not just casualties, they're proof of the universe's boundless creativity, scattering raw materials for new stories we can't yet imagine. A world flung into the abyss might someday be captured by another star, its frozen surface thawing under a new sun. The ingredients for life, once thought lost, could get a second act. This duality, destruction and renewal, echoes through human history. We build cities on fault lines, civilizations in the shadow of volcanoes, knowing catastrophe could strike at any moment. But we build anyway. Galactic tornadoes are no different. They tear down, but they also scatter the seeds for what comes next. In that sense, they're not just forces of chaos, they're agents of change, rewriting the galaxy's story one exiled world at a time. So when we look up at the night sky, we're not just seeing stars, we're witnessing a universe that's alive, restless, and endlessly reinventing itself. And somehow, against all odds, we're here to see it. Every rogue planet drifting through the void is more than just a cosmic anomaly. It's an invitation, a beckoning whisper from the universe urging us to look deeper. These lonely worlds aren't just floating debris, they're pages torn from the galaxy's diary, each one holding secrets about the violent forces that shaped our cosmic neighborhood. Imagine holding a piece of driftwood washed ashore. Its grain tells stories of distant storms, ocean currents, and the passage of time. Rogue planets are the interstellar equivalent, their very existence a testament to the gravitational upheavals that can tear worlds from their homes and send them careening into the unknown. The hunt for these celestial nomads has become one of astronomy's most thrilling frontiers, pushing our technology to its limits. Projects like the Vera Rubin Observatory's upcoming Legacy Survey of Space and Time will scan the skies with such precision that they might spot hundreds, if not thousands, of these dark wanderers by detecting the subtle dimming of background stars as planets pass in front. It's like finding needles in a galactic haystack by watching for the momentary shadows they cast. Each discovery adds another day to point to an emerging map of cosmic chaos, showing us where and how often these cataclysmic ejections occur. But the real magic happens when we connect these findings to the bigger picture. Some rogue planets move in clusters, their parallel trajectories hinting at a shared violent origin, perhaps all flung outward by the same galactic tornado billions of years ago. Others drift alone on bizarre paths that cut across the Milky Way's spiral arms, suggesting they were exiled from another galaxy entirely during a long-ago collision. By tracing these trajectories backward like cosmic detectives, astronomers can reconstruct ancient celestial crime scenes, identifying which regions of our galaxy have been most turbulent over its 13-billion-year history. What makes this exploration so compelling is how it reshapes our understanding of planetary survival. We used to think habitable worlds needed to orbit stars at just the right distance, the so-called Goldilocks zone. But rogue planets challenge that assumption. Some may harbor deep subsurface oceans kept liquid by radioactive decay or tidal heating, their icy crusts acting as natural insulation against the cold of space. Others might have thick hydrogen atmospheres that trap geothermal heat like cosmic blankets. If life can persist in these extreme environments, it means the galaxy's habitable real estate could be far more abundant and far stranger than we ever imagined. This isn't just about cataloging celestial bodies, it's about rewriting the story of our place in the cosmos. Every rogue planet we find forces us to reconsider what's possible, what's common, and what's waiting to be discovered in the vast dark between the stars. They remind us that the universe doesn't play by our earth-bound rules, that nature's imagination far exceeds our own, and perhaps most importantly, they prove that exploration isn't just about reaching new destinations. It's about learning to see the familiar sky with new eyes, recognizing that even the emptiest patches of darkness might hold worlds beyond our wildest dreams. From their violent birth to their lasting impact, galactic tornadoes stand as titanic reminders of the universe's raw, untamed power. These aren't just cosmic storms, they're architects of change, rewriting the destiny of entire star systems in moments of unimaginable fury. Picture the forces at play: supermassive black holes colliding with the energy of a trillion supernova, gravitational waves rippling through space-time like shockwaves from a celestial detonation, and planets' entire worlds being hurled into the void like pebbles from a slingshot. The scale of destruction is matched only by the strange beauty of what emerges from the chaos: new star systems born from scattered debris, rogue planets carrying the potential for life across interstellar gulfs, and cosmic elements forged in the heart of the maelstrom, eventually finding their way into planets like our own. But beyond their spectacle, these phenomena serve a deeper purpose. They're cosmic teachers, pushing the boundaries of our understanding. Every time we detect a rogue planet or observe the aftermath of a galactic collision, we're glimpsing the universe's hidden operating manual. The physics at play in these extreme environments doesn't just challenge our theories, it refines them, forcing us to rethink everything from relativity to quantum mechanics. When a planet survives ejection against all odds or a black hole's spin defies predictions, we're not just witnessing anomalies, we're being handed clues to laws of nature we haven't even discovered yet. Perhaps most humbling is what these storms reveal about our place in the cosmos. For all our technological achievements, we're still just observers of forces that have shaped galaxies since long before Earth existed. A single galactic tornado can unleash more energy in seconds than our sun will produce in its entire lifetime, a scale of power that puts human concerns into sobering perspective. Yet there's wonder in that realization too. The same chaotic processes that fling planets into darkness also scatter the building blocks for new worlds, new stars, and potentially new life. In the grand cycle of destruction and creation, we're proof that sometimes, against inconceivable odds, the universe turns chaos into something extraordinary. The exploration of these cosmic tempests is far from over. With next-generation telescopes and gravitational wave detectors coming online, we're on the verge of seeing deeper into these storms than ever before. Will we find evidence of quantum effects playing out on galactic scales? Could rogue planets turn out to be far more common and far more habitable than we ever imagined? Every discovery promises to reshape our cosmic worldview, reminding us that the universe is stranger, more violent, and more magnificent than we've dared to dream. If this journey through the cosmos's most formidable storms has sparked your curiosity, you're not alone. The study of galactic tornadoes isn't just about unraveling astrophysical mysteries. It's about connecting with the awe-inspiring forces that shape existence itself. Whether you're a seasoned space enthusiast or just beginning to explore the wonders above, there's always more to discover. So keep looking up, keep questioning, and remember, the next great cosmic revelation might be just one observation away. For now, we'd love to hear what cosmic phenomenon blows your mind the most. Drop your thoughts in the comments. And don't forget to subscribe for more deep dives into the universe's greatest mysteries. The cosmos still has countless stories left to tell, and we're just getting started.